Okay, all right. So now talking about DevOps, right? Anybody, any idea apart from Mithun? Because Mithun, I think you have already attended a little bit of this. But apart from Mithun, anybody else, any idea on? I mean, what idea do you have about DevOps? Anybody? Yes? No response?
It's like a the intermediate thing between the development and operation.
No, 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 and not at all. I mean, good answer by the way. Nice way of thinking, but no, not exactly. Okay, let me tell you in this way. In one single line, DevOps is a automation of the software industry. Okay? Automation of the software industry. So in software industry, how does it work? Okay, let us try to see. Hang on a second. All right. So in software industry, how does it work? See, basically, if we talk about the software development life cycle, which you need to know in order for you to actually understand this thing, let me open up notepad. So there are certain things which you need to know that how the software industry works, right? So the first thing that you need to know is that there is something known as software development life cycle. Okay. In software development life cycle, the first thing that happens is basically known as a requirement gathering. Okay. When there is a software project, an IT based software based project, the first thing we do is we try to gather the requirement. What are the things we need to do about it? People who are not talking, you can mute yourselves. I'm getting some noise. Some kid is shouting. Okay. Requirement gathering. And after that, we have got feasibility analysis or feasibility study, anything you can call it. Feasibility studies, so the requirement that we have gathered, okay, these things we need to build. Do we have enough resources or enough infrastructure to build that thing? Okay, that is called feasibility study. Requirement gathering, feasibility study. After feasibility study comes design. If feasibility study gives a positive response that okay, fine, we have enough infrastructure, we have enough human resource to work on this. Maybe we can hire some people and we can start working on this. And then we go for design, right? Design means structure. I'll just kind of write down in the. So requirement gathering is about understanding what the client needs. Feasibility study is all about, you can say, realizing whether the requirement can be met at current IT situation. When I say IT situation, I mean the IT resources, every single thing, right? The infrastructure of IT, etc. Probably you need to make something which you need to host on AWS, and you do not have a person who knows AWS, so you cannot do that. You need to hire someone, right? So realizing whether the requirement can be met at the current IT situation. Then comes the design. So that is documenting the module based structure of the software application. When I say document based structure, module based structure, what I mean, okay, I'll explain you this point in a moment. After that, we have got coding, right? Where what you do, write codes for actually developing the modules, okay? Designed modules. And then after coding comes testing. Okay, what is testing? Doing analysis of the developed modules to find out if it complies to the actual design. Okay. Ultimately, I've got deployment, which is putting the prepared. Oh, it went over there. Prepared module. When it's a prepared module, the application, software application, right, on the production server. And then comes maintenance, which is um, keeping track of performance, checking for any potential issues, and resolving. Yeah. Okay, these are more or less how many steps did I write? 7. Okay, 6, 7. It depends how you're writing. Some people write requirement and feasibility together. It will become 6. Whatever it is. So this is the usual flow. Now let me try to take an example. Let me try to take an example of a software which all of us knows, and we can give the example with that. Do all of us know about Google Pay, GPay, Google Pay? Right. Everybody knows about it, right? IES will help me. Hello.
Yes,
Yes,
yes.
sir.
Okay. So Google Pay, Paytm, this kind of things, right? So let's take Google Pay. Google Pay developed by Google, right? So first thing that comes into picture is requirement gathering. So understanding what the client needs. What is the client over here? The client is the generic public, right? Google Pay, the client is generic public. So I'll again write down these steps, but this time from the perspective of Google Pay. And trust me, after I have done this, you will never forget it for your lifetime. Requirement gathering, that is what requirement they gathered? UPI based payment through QR code scanning, right? That was the requirement. Initially Google Pay came with that. Later they added more modules like your what was that, Diwali stamp collection, whatever. But gold also they have brought, right? So whatever, mobile recharge. But initially this was the only purpose of Google Pay. 2 years ago when it first came, UPI based payment through QR code scanning, right? And another requirement they found out, that was sending money through phone numbers registered on Google Pay, right? This was the main idea. Tez, they call it Tez, right? That point of time. Okay. Now, feasibility study, whether this particular requirement that is over there that can be met at the current IT situation or not, right? How to do this feasibility study, or how to actually go ahead for doing that. So, so feasibility study means what IT infrastructure or whatever resource we have right now, can we do it or not, right? Now you can understand if it is Google, it is feasible. I mean, Google does not fall short of employees. They will have enough number of employees, the best employees in the world probably. So feasibility study is anyway a big okay, right? There is no issue over here. So let's say I'm saying yes, we can do it, right? Next comes design. Design means documenting the module based structure of the application. Here there are two things basically. One is that you need to first take the application and break it down into multiple modules, and then you can document. You have to document it. So document the module based structure. So what are modules we have? We have modules like, one is QR code scanner. Achha, first one is the user registration module, right? Where you need to put your phone number and all those things. What else? Tell me. We have got QR code scanning module. What else do we have? We have the okay. Sending money module, money sending, right? So money transfer. Is everybody understanding what I'm doing? Is everyone clear? All of us.
Yes.
Money transfer module. Let's keep it simple till this point. Let's not go. I mean, probably we can find out many more modules if we want to. Let's keep it simple. Then next comes the coding, right? So that will be done by the developer, of course. So what they will be doing, they'll be actually developing the modules and putting them together, right? That is the thing that is done over here, which is one of the very vital steps. All the steps are very vital. Any step you miss, you are gone. Your application will not, I mean, you will not end up making the software you're trying to make. You will not finish that. Any step you miss over here. Think about it. Someone gathered a requirement, directly did the design without doing a feasibility analysis. And after they start coding, they find out, okay, they are missing some specific thing or a specific technology, person he needed, which is not there with them, and the project gets stuck. Any step you miss, you're gone. You do not take a proper requirement. You just, on a high level, you just understand something and you start building. You end up making an application which was way different from what your client was actually expecting, just because your requirement gathering was not done in a correct way. The designing is very poor, the coding follows the design, and it ultimately ends up becoming in a very under standard coding, right? So these are certain things you need to keep in mind. Okay, so now developing the models and putting them together, this is something that we are doing. After that, we are trying to do the testing, right? So testing, if testing is also known as quality analysis, right? That is the actual name of testing. Testing is something that we say normally, but it is actually QA. So QAing the application by checking each of the module functionality, and then comes your deployment, right? So this is the movement to Google Play Store, correct? That is what it is. Deployment means over here movement to Google Play Store, and on the Google servers. Google server will be having the actual application. In the Play Store, you'll be having the app which you can download, and through that you can access the application. Right? Okay. And then ultimately maintenance. In maintenance, right? So bug fixes specifically. So like they'll be seeing collecting the bugs from Google Play Store reviews, right? In Play Store, people will put 1-star review. They'll write this thing is not working. Play Store review is there, and what else? Maybe some online Google threads. Threads means what? Discussion threads. Over there, they will find out these things and they will try to fix that bug. Clear, right? Any doubt? This is how any software, if you think about it, you can actually align it in this particular way. You will be able to align every single software that you know of in the market. That can be even your Microsoft Word, Microsoft Excel, PowerPoint, these kind of things. Every single software, if it is a software, whether it is available online or offline or whatever, that can be always put down into these 7 steps. Right? And the question is, why am I talking about this, and where is DevOps all about? Okay. If you have understood this part, then let's understand the next thing. That is, when we are doing this, how we are doing this. What is the way of aligning these steps, these 7 steps of action? How we are aligning this? Let me copy it. Okay. So there is something known as, or there was something known as the waterfall model of software development. Okay, waterfall model of software development. I'll just paste the same thing once again. I'll show you how it used to be. I'm just deleting this brackets. Okay, bracket things I'm deleting. I do not need them anymore. Hang on a second. Delete all of this. Okay. Waterfall model was like this. You take the entire requirement. Okay. then you do the entire feasibility, which, I mean, just think about it. If you take the entire requirement together, every single thing is required to be having on the tab. Google Pay, how they did an incremental, right? First they launched something, then they added features. But if you do everything together, you want to make the entire thing together, you will be doing a feasibility study. Okay, I have this many resources, I'm working. When you actually need to do that work, let's say it takes you 1 year of time to reach, no, to the completion, or 2 years of time to reach to the completion. In the meantime, someone leaves your organization, they leaves your job, right? So you are falling short of resource. It is never a good idea to take the entire thing together, right? Feasibility study also should be done in a periodical way. Okay, I am trying to build this, is it feasible or not? I'm trying to build this, is it feasible or not? What do I need to do in order to make it feasible, right? But anyway, so they used to do it like this: entire design, okay, entire coding, then comes entire testing, entire thing is getting deployed, right? Ultimately it moves on to maintenance. Okay, so now why this is called in a waterfall model? Because if you see, this looks like a waterfall, step by step, like staircase kind of a thing. Here, if you, I mean, what is water? Water is like a staircase, right? Falls from top to bottom. So it falls from top to bottom: requirement, feasibility, design, coding, testing, deployment. It is done. There is no reverse approach, right? So in this thing, there are many downsides of this. The biggest downside was that it used to take a huge amount of time. Let's say now, if Google Pay thought that we will be adding this Diwali stamp in the very first day when Google Pay was launched, they would have not been able to launch it at that point of time. They would have need to work features. Probably Google Pay would never have launched, I mean, honestly speaking, if they think of putting everything together, right? So you need to put a little thing, make it workable, you need to produce it and keep on extending on that. That is, and that sounds so, I mean, so realistic, right? You just do a little bit and you produce that. But earlier days, people did not think like that. They used to think, we'll make the entire thing and we'll release it. So we are rock stars, so we can just make the entire thing and release, and it will work perfectly fine, which didn't happen actually. It took a huge amount of time. So downsides were time constraint, okay, and also effort constraint. How? Now, when a developer is doing the entire coding means a complete application, every module, everything, sending it for testing. Now, testing will take a huge amount of time, right? Because a lot of things are there. Now, this huge amount of time this testing is taking, and definitely when you are doing testing, you will probably find out some mistakes. So you give it back to the coder. You say that, hey, these things are wrong, fix it. Now, let's say coding took 8 months, 10 months of time. Testing itself took 2 months of time. Now, after that, you are again giving back to the developer saying something is not working, and the developer probably worked it in the first month. Now already 12 months have passed. Can you understand how big effort he has to put again to find out where in code the mistake is there and every single thing, right? Probably he needs to change a complete logic, or, I mean, it's very difficult from the coding perspective to fix something that was done way ago. Probably some other developer did it. That developer left the job, new guy came, he is finishing it off. Now you have some problem in the older code. This guy has to read the code, understand what is going on. So that's terrible. I have seen these things, trust me. TCS still follows waterfall model, right? It is very impractical. They cannot follow a actual waterfall, but they kind of, mix and match of waterfall. Very difficult to work over there. So the effort constraint is very high, and that is why this kind of companies, TCS, Infosys, Accenture is a little bit better right now. This, as at least what I've heard. So this kind of companies, projects keep on going for delayed. They never finish on time because of this kind of constraints. Because they are using a very old model of, software application development. So anyway, so you can understand time constraint. In fact, this also happens that you start making an application, by the time you finish it, your client has already probably shut down the business only. You have taken so much amount of time. This kind of things happen, right? Or probably they do not need it anymore, they need something more advanced. But after 3 years you are completing a project, and that is like 3 years old, right? Doesn't make sense. So what they did, they went for something known as agile. Anybody heard about agile model of software development? Anybody heard about this term? Can someone tell me what it means? Anybody? Yes, no? Hello?
Yes.
No? Okay, you heard about it? You know
Yes.
what it means?
It's a continuous improvement uh, strategy.
Yes, I'll explain you what it means. I'll explain it for everybody. You're correct in stating that. So what happens, see, these things, you are, instead of taking the entire chunk together, you're doing it bit by bit. Okay, so how you do? You do like this. Let's say you take a requirement, okay, then you do the feasibility study, right? And then you go for designing that part, right? And you go for coding that part, testing. So what we're doing, we're doing the same thing, but we are doing it in step by step. Step by step, you do not take the entire. So instead of writing one below other, I'm writing in a single line. We are taking step by step. So let's say there are these many modules. You first take the, okay, we need to do, say we found out there are 3 modules, that is the requirement. We are just checking the feasibility and we start with one module, right? We are designing the user module. Okay, after designing user module, you are giving to the coder that, hey, do go and develop this user module. Okay, this is the design, this is how it should be. While he is doing that, he already started taking the second module, that is the QR code scanner, right? So the QR code scanner you started working on designing, right? So the parallel working you are doing. So by the time coding is finishing it, it is handing over to the testing for testing out the module. Till that point, from design it comes to the coding, right? Then the next module. So it keeps on flowing like that. So everybody is working parallelly. Some problem is there, you fix it then and there, small parts, right? And you keep on deploying them in small parts only, right? Keep on deploying them in small parts only. So slowly one hour features you are keeping on increasing in the production. That's what you're doing. So this becomes much more easy, right? But agile has a particular problem. Okay, agile has a particular problem, and that is maintenance. What is the problem in maintenance? The last step. The problem is, since we are doing small parts and we are continuously releasing it, here we have a very strict deadline. Because if you don't have a deadline, and if even one single part you take a more amount of time, your entire software application release date becomes, extended, right? Because it is like bits and pieces you are taking. Any piece takes more amount of time, the things that are following it will automatically become delayed, right? So you have a very tight deadline over here. In maintenance, if something is found out, some issue, okay, some module is failing or something in production, that comes back to the coding team for fixing. Now the coding team has a very hard time whether they will fix the production issue or the current module that they're developing, right? Because this module also has to go to production within a given deadline, and the production module already that is in production that has got some issues. So whether they work on this or work on that, this kind of situations started coming in, right? So they started faltering on their deadlines. Agile, the biggest problem with agile is that when a software is small, agile is fine. If the software starts growing big, they start faltering on their deadlines, because the more parts you send on production, the more bugs you might face, the more you have to rework on that. So to support this, you can hire more coders, but I mean, how big will you make your team? You cannot keep making your team infinitely large, right? You have to somehow make sure that you are doing the work within a finite amount of members. That thing failed. What came next, or not exactly next, or what came as a preventive measure to this particular thing, is known as development in operations. In short, DevOps. So what Agile did, if you see, it kind of automated this section. You are designing a part, sending it to coding, going for testing, and module one is a design. Coder and tester is sitting idle. Module one goes to coder. Module 2 comes for designing. Module 1 goes to testing. Module 2 comes to coding. Module 3 comes to designing. So one after one, new modules you are taking, and you are passing whatever you are finishing up to the next guy in the hierarchy, right? So you are just sending it one after. So it was an automated cycle that was going on. But this automated cycle was only over here, and you are pushing it to production, whatever. Only over here in the so these three things, if you can see, they are all related to making of the application, right? I mean, only coding part is technically the development team, but actually all these three are related to development of the application only, right? Designer, if he does not design, the coder, what will he code? And the coder does not coding the code, the tester has to test. If he does not test properly, then this code has no value. So ultimately, these three things are the development itself. Even though coding is what we mainly call as development, but this is also development, right? So this is dev in DevOps. Typically development just means this one, but from DevOps perspective, this entire thing is related to development. So this entire thing is known as dev. Okay. So the dev automation was anyway done in Agile, but the part where the failed was the operation automation, operations, which comes from deployment. Okay. How? When you talk about deployment, we are talking about network scenarios, talking about server management, we are talking about the deployment management itself. Okay, you're talking about the uh, okay, in the server management it comes in picture, like which security patches, what is the latest updated version you need. For example, a Java application you are making, so you need to have Java version this much, because the application is made in Java 10 and you are putting Java 7, it will not work out, right? You need the latest version of Java and all those things. So this entire thing, actually it is not network, server and deployment management, it is a management of all these three things together: networks plus server plus deployment. This was the section which was not taken care over here. Okay, that was not taken care, and that is why these issues started coming more and more. So think about it: something fails on production, you are writing a code in Java and you are using Java, let's say version 10, and in production, let's say that is Java version 8. Now the code that you are writing right now, that even though you are using Java 10 on your local machine, but you are not using any advanced feature of Java 10. What you are using, that is present in the older Java version also. So this code was working fine, but one day you write a single line of code that is using the latest version of Java features, and that is not there in the older Java that is over there. Now that line of code, that Java will not be able to parse, it will fail over there, right? It will not understand what this code means, right? So at that point of time, you will get some production issues. From the front end, you will not understand. You will just see, okay, I am clicking on this button, nothing is happening. But internally, that is failing over there, let's say. So that means what? If the server management was done properly, this issue would have never come. So now it is coming back. Now see, you cannot miss on your deadlines, right? You cannot say no, because the production issues are coming, I want my deadline to be very long. You cannot do that. Your deadline is stuck for 10 days to it is 10 days, 15 days to 15 days. You cannot say no, some production issues might come. I have a little amount, a small team, so I would like my deadline to be 45 days. Doesn't make sense. Or if it is 45, it is 45. You cannot make it 60. You cannot do that, right? So you have to take care in the operations to make sure that operational issues do not come, because most of the actual bugs are anyway caught in the testing phase. When you're doing the testing, the design, coding and testing, right, the testing phase, most of the bugs are identified. Still any bug is coming in production, that means there is a difference between the environment that is present in the production. That is why it is not performing the way it's supposed to perform, the application, right? Environment means software environment. I do not mean environment means houses and trees. I mean software environment, the version of Java, the version of the operating system, the version of this, that, whatever. So that thing is not matching. That means if a operations guy was sitting and he would have known that, okay, this application that is getting deployed, it requires this version of Java, he would have just updated the Java over there. It would have never come back. And now what is happening? It is coming back. You are analyzing, you are finding out the issue, then you are deciding, you are again going and fixing it. It takes a huge amount of time. DevOps is all about making sure that agile is actually agile. Agile is not getting slow, right? It has that agility. So DevOps is not a replacement of agile. This question is asked: do you think DevOps can replace agile? This is a very wrong question to ask, because DevOps is never trying to replace agile. DevOps is a kind of a plugin that you are putting into Agile to make Agile more solid. Okay, just like let's say someone is cooking Maggie and you are putting some vegetables in the Maggie, so you can sell it in more amount of price because you are selling it becomes veg Maggie. Maggie was originally veg only. Maggie was never non-veg. You put some vegetables, you cut some cucumber, put over there, you sell it in 20 rupees more. So that is what DevOps is doing. It is an ingredient that you put and you make your Agile even better compared to the standard Agile, right? That's what it is. Anybody any doubt on this point? Yes? Yes, no? Please respond.
No, no, no doubts.
No doubts. What about others?
No doubt.
No doubts, right? Sunil, clear?
Yeah.
Okay. Right. So now that we have understood this thing, now the question is that how is the DevOps life cycle? I think I'll share this this with you. This page I'm writing. Okay, I'll just copy and paste in the chat. Copy with yourselves. Okay, I'll do that at the end. Let's not break the flow. Now, how is DevOps actually working over there? Okay, so the DevOps flow is like this. Okay, number one, developer. Okay, see, I am omitting the design part. Okay, I'm just starting. Like honestly, if you see, the design part cannot be automated. I mean, through software automation, you cannot do it because designing a man has to sit and do it, right? The coding part, a human has to do and write the code. Code cannot be automated. But after coding, every single thing, testing can be automated. This network connection checking, server, management, deployment management, all these things can be automated. So I am starting writing the flow just after the coding is finished, just from this point. Okay, from here I'm writing the thing. So developers upload their code. First I'll write in layman term, then I'll actually use the terminology. Okay, developers upload their code in a repository means what, where you can keep the code, right? So everybody can see it. Whoever is the authorized people, they can see it, right? So developers upload their code in a repository. Then what do you do? Then okay, so testers write test script, which you know is run on the code that has been uploaded, right? So developer uploaded a code, you take that code, you run the testing on that, right? You try to test whether it is working or not, right? So then what do? You try to kind of if everything goes well, we try to deploy that on production, or if it is not on production, maybe a intermediate server you want to put because your client does not allow you directly to put on production. May happen, depends on your client, but typically let's write it production only. Okay, because from my organization perspective, I have done every single thing. My coders, my testers, everybody has done, my DevOps engineer, and now we are telling that okay, this is fine. Now it is on client whether client allow me to put directly on production or says no, put on an intermediate server. We will take it on production by ourselves. Okay, go ahead and take it. We are giving a sign off. That's the idea. Okay, if everything goes well, deploy that on production, right? And then monitor maintenance, right? You are monitoring what is going on. There is maintenance. Monitor the stuffs. Um, when I say stuffs, I mean both monitor the application, the software that you have written, how it is working or not working, it is up or down, it is responding or not. Monitor the server also. I mean, that physical server where you have deployed it, the server is working or not, because both you need to monitor. Operations, you need to do it, right? And at the same point of time, okay, I should in fact write it down over here. 2.5, I mean in between 2 and 3, okay, or I'll just call it 3 and this one 4. Okay, 5. Okay, so actually if everything goes well, have a check on the environment in production. And see if it matches to the expectation. If not, then work on that, right? So if yes, deploy on production. If no, first prepare the environment, then go for deployment. Clear? So you are ruling out that possibility that some version mismatch, something is happening and something is going on, and then monitor the stuffs, that is application monitoring, server monitoring, etc., etc., etc. over there. Right. This is the DevOps flow. Fine. This is
Hello.
tell me.
Sir, I have a doubt.
Hmm.
Repository means it's a kind of cloud or it's a external memory thing.
You can think of Google Drive also. Google Drive is like a repository. You can share photos through that. You upload a photo over there, you give someone permission, they download the photo.
Okay, okay,
Repository means a place that can be shared with multiple people.
okay.
Typically, it is on cloud only. Google Drive is on Google Cloud. Okay. I mean, it can be S3 also. Let's say it is S3. In S3, you are uploading a photo and you are giving someone an permission to access that photo.
Yeah. Okay.
Typically, most of the applications nowadays are using S3 only. Yesterday, I was having a discussion with a guy. There is a place called Springboard, near Vega City Mall, right? Near to Vega City Mall, over there is Springboard. Last night I was at Springboard, so one company was there. I was doing some discussion with them, so they gave me a call. I went there. Me and Gopi went for that meeting. So they are using a customized CRM application, CRM, customer relationship management. Okay, CRM application. So the customer photo they are taking, they're using AWS. That is why they consulted me actually. So the photo they are taking, they are storing it in S3. So they have got AWS developer who is writing code, pull it from S3. Right? So they are not very sure about the permissions and all those things. So there is a thing that I have to design for them. So S3 is the most widely used because it is very cheap, right? Extremely cheap. First 5 GB it is free. So if you are not running an EC2 and all those stuffs, let's say you are doing in physical, but just through API you are pulling the data from S3. Just S3 you are using. 5 GB it is free. Now if you are taking user photos, right, customers photo, first of all, not everybody uploads their photo. If some people upload their photo also, how big will a photo be? 20 KB, 30 KB maximum. So 5 GB is enough. I mean, they can operate probably 1 year free of cost, right? So that's what they're doing. Okay. So we are doing this application monitoring, server monitoring, all those things. Now writing this entire thing once again in actual terminology. Okay. So DevOps flow, once again, DevOps flow. Okay. With jargons, actual technical jargons. Okay. Number one, developers upload. It is not called upload, it is called push. Okay, I'm writing, I will write in capital. Okay, the jargons: push their code in GitHub, okay, which is a repository. Then what do? Now we are trying to automate, right? That I am not asking my tester to actually download the code and run the testing on that. I'm automating everything. I want everything to be automated. It's a software industry automation, right? Remember this point. It should be automated, no manual work. This last manual work you will do is to push the code on GitHub and then you stop. Everything will be automated, right? Jenkins, a tool, okay, known as a continuous integration tool, CI tool. Jenkins fetches, or okay, not fetches. Jenkins checks the git status. Git status is a Linux command. I'll show you. Jenkins checks the git status, means any new code has been uploaded or not, right? Periodically. Typically 1 minute. Every 1 minute. Okay. It checks the git status periodically, and what it does, it pulls. I read this in small. It pulls the newly pushed code. Okay. And pulls means pushing means sending to GitHub, pulling means so uploading and downloading simply. Okay. It pulls the newly pushed code and just pulls it. Okay. Then number 3, test cases shall already be. Before testing, there is another step which is not shown over there, but it is required. The code is built. Okay, I'll not write built because the thing is built. I'll just write builded, even though it is wrong grammar. But let's write like this. Okay, I'm not writing built. The code is builded. Okay, so what this means? This means compiled. You heard about the word compiling? You write a code, you need to compile that, right? So it is compiled. Okay, that is what we do in building. We compile the code, right? We compile the code. Achha. Using, or I should say, Jenkins builds the code using, that will make more sense. Builds the code using Maven. Maven is a tool that is used for building. Okay. After building means, because if you do not compile, you directly cannot test a code. You have to first compile it. So that compilation has to be done using Maven. If everything goes well, just like it is written over there, right? No, then it is written the tester write the test script. Okay, so testers has written the test script that is already written, let's say. So the test scripts are configured on Jenkins, right? And Maven takes those scripts and runs a test on the compiled code. The code has been compiled, right? So on the compiled code, Jenkins asks Maven to take the script and run it, right? That's what it is. So we shall be using Selenium for this. You can use anything. Selenium is a widely used testing tool, you can say. We shall be using that, right? There are certain limitations of Selenium, certain advantages of Selenium. All these things we shall learn when we actually learn the Selenium. But remember, you are not, I'm not trying to make you a tester or a developer. You do not need to know everything about, let's say, Git is fine, Git you need to know, but Selenium, you do not need to, because Selenium code is written in Java. Now, I'm not asking you to learn Java and write Selenium code. No, you tester will give you that. You need to know how you can set up Jenkins in such a way so that it can take those things and perform the work that you want to do, right? You are not writing the test script. You are no way related to writing code at all. Okay. Achha. Then comes, now once this testing is done, then what is the third step over here? You can see step number 3. If everything goes well, we have a check on the environment in the production, see if it matches the expectation. For that thing, we have 3 ways, 3 options. Jenkins fires a deployment on Docker's Swarm, I just call it Docker, not Dockers, or Kubernetes. Okay. Docker is for single server deployment. The way we are doing on AWS, let's say. What we are doing, taking one server, on that we are running Apache. Right? Is for single server deployment. How Dockers work, that we shall see and understand later. But as of now, understand that it can have a check on the environment also and then work on that. Swarm is for cluster-based deployment. Same is the case with Kubernetes. Okay. Number 6. So you have done your deployment either Docker based or single server or cluster based, whatever it is. Then what you do? Nagios is used for monitoring the server and the application, right? When you say monitoring, I mean in the no, just to make sure you understand, it is doing a health check. Server means doing a health check on the root on the server, and application monitoring means what? Pinging on port number 80, because the application typically runs on HTTP. If it is HTTPS application 443, pinging over there and checking the TTL to figure out whether it is working or not, right? So there are a lot of setups we need to do in Nagios. We need to take the servers where our application is running, put that into Nagios. A lot of things are there. Number 7. Any environmental maintenance job, environment based, leave it. Any maintenance to be performed, because when you talk about DevOps, it is just environment only. There is nothing apart from non-environment maintenance is not there. Maintenance we performed using Terraform, Ansible. Okay. This is your DevOps flow. Right. The tools we are learning is there is Git, GitHub, both Git, GitHub, Jenkins 3, 4, 5, 6, 7, 8, 9, 10, 11. These 11 things we need to understand. We need to see how they're working together. Individually tools you can learn from anywhere. That doesn't make sense. You need to know how to work with them together, right? Because everything you have to. Acha. This part from 1, 2, 3, 4 till this point. So 1, 2, 3, 4. I'll just write it down over here. Right. 1 to 4. This is known as continuous integration, or in short CI. 5, actually it is 2 to 4. 1 is just pushing the code. 5 is your continuous deployment. You heard about this term, CI/CD? CD. Okay.
Yes.
All right. Then this is known as continuous monitoring. This number 7 is known as configuration management. CM once again. Achha. Now, um, 3 is known as continuous building. This is the actual terminology of this one, DevOps. It is not called CB, by the way. I was going to write it. It is not called CB. There is no such word called CB. And number 4 is continuous testing. Okay. Achha. This is also not called CM. Sorry about this. Only configuration management is called CM. So when someone says CM, they are not talking about continuous monitoring. They're talking about configuration management, right? These are the terminology. I'll quickly copy and paste this thing in chat. Please copy them with yourself. I'm quickly doing it. Okay. So, hang on a second. Sorry. Chat. Oh. Okay. Are you copying it? I'm pasting it. You got it, right? Coming in chat. Keep it with yourself, please.
It's better to save this file and after in the
Google Drive.
Google Drive.
Okay, fine. I'll do that.
Will be fine.
I'll do
So
that.
it will be a PDF file.
Fine. I'll do that. Okay. That's a good idea. Okay. Any doubt on anything? Right?
So, Vishal Mithun here. One doubt I have is Jenkins can also be used for deployment directly on EC2 servers, right?
Jenkins can be used for everything. I mean, in fact, Ansible also can be used for deployment. We are not using Ansible for deployment over here, but using Ansible also you can do deployment. These tools individually they can perform a lot of things. But what we need to do is that we need to see how we can fit it in the DevOps architecture. Each individual tool can do a lot of things, right? We are not trying to master each tools 100%. We are trying to see how these tools are participating in the DevOps architecture, and we can use all of them to do a DevOps thing. Jenkins can definitely be used for doing the direct deployment also, without using any Dockers or anything. But deployment has to be done on Dockers. I mean, if you are using only Jenkins and not using Docker technology, then it is just like copying the file, copying the package in the web app directory so that it is accessible. It will not be a containerized thing. But DevOps talks about containerization, which can be done only through Dockers. Typically, through Ansible also. Ansible also you can do, because the ultimate deployment is nothing but a copy paste. Okay? Deployment is nothing but a copy paste.
Mm-hmm.
Copy paste can be done using Ansible also. So yeah, that's the point. We can do a lot of things using a lot of this, but how we take them and intelligently we put them together to perform a particular pipeline method, that is the most important thing of it.
Mm-hmm. Okay.
Anybody?
Vishal,
Tell me.
this third point, it says Jenkins builds the code using Maven, right? So Jenkins Maven is compiles the code and execute the code. Maven.
Nobody is executing the code. There is no executing the code concept over here. Compilation of the code is being done by Maven. So what you are doing, you are telling Jenkins. I mean, we have a lot of plugins in Jenkins. So we install the Maven plugin so that it can actually do a Maven build. Maven is a building tool. Okay. So using that, build means compilation. Compilation, packaging. It can be compilation. A lot of things. Let's say compilation plus packaging, right? It can be. Packaging means, let's say a lot of Java files are there, or writing a Java code. You package them together into one single,
Correct.
exe file kind of a thing. It is not exactly exe file. It is known as a WAR file, WAR, which stands for Web Archive. You will understand this thing when you do Maven. It creates the packaging will give you a .war file. It is not war. It is not youth. It simply means Web Archive. Okay. You sometimes you might find jar file also, which means Java archive. So there are different file formats that come up. So that is what packaging is. This war file, if I copy and put in a, let's say Apache Tomcat, this one, I mean, web app directory, it will able to run that. You restart the Tomcat, it will start running the application. Right. So that is what deployment is: taking the packaged file and putting it in the correct directory, so that the web server or the application server, not web server, sorry, application server can read that and run it. Okay, that is how it works.
And all these tools are free of cost, or is it like a chargeable?
No, it is not chargeable. It is all of them are free of cost. In fact, they are all open source. You can change the source code if you know coding of the tools. I mean, you can change the behavior of the tool itself. I'm not suggesting you to do so, but I mean that is the kind of freedom you have with these tools, right? Anything else? I will not go any further today. I'll stop over here only. Any question? Because this was a very vital thing to understand. Acha, for the people who have joined, in the DevOps part only, let me just pull out the list of this thing. Okay. So Junaid, Sunil, Mithun. Acha, Prasad was also not there in the AWS discussion. Prasad has just joined just now. Oh, okay. 15 minutes. Okay. So, guys, we are sitting tomorrow as well. Okay. So tomorrow at morning, it just for this Saturday. I mean, going forward, your class will be from Monday to Friday only, as it was scheduled earlier. But this Saturday we are sitting because of the gap that we that has got introduced. I was expecting it to start a little early. I mean, not on today, at least 2 days back. But since we have got this gap, so we will sit tomorrow as well at morning 8 itself. Everybody's free, right? At
Yeah.
morning 8 tomorrow.
Yeah, Vishal.
Okay.
So
Vishal,
can we
class
have
will
a
be 8 to
class?
8 to 10 or 2 hours class or 1 hour class?
Around that only 10:30 probably something like that. Because at 11 I have another session, so I have to anyway finish off before that.
Okay.
Yeah.
Sir, we should
Yeah.
learning DevOps means we should have a knowledge of Linux also, right? Thorough knowledge.
In Linux, you already did a lot, right? When you did AWS, already you did a little bit of Linux over there. So, I mean, the entire thing
Yeah.
is going to be on Linux only. On AWS also, when we were reaching the end, we were
So
working.
can we have 1 or 2 class on Linux also?
Sorry?
Because we are not familiar with Linux.
No, what do we do Linux once again? That was already done no? When we started AWS. So, for the people who go for both AWS and DevOps, even though in syllabus it is written in DevOps, I usually do it in the beginning itself. So, AWS, sorry,
Lot of disturbance is available to hear.
yeah, it will not be difficult. Don't worry about it. I mean, once you start working with it, you will get a complete thing.
Yeah, Vishal, from
Yeah,
today onwards, your classes will be started from 8, right?
I am getting noise from someone. Hang on a second, because I'm unable to hear you.
Vishal, lot of disturbance.
Exactly. Yeah, tell me, Prasad, what were you telling?
Your classes will be started from today onwards at 8 a.m. in the morning, right?
Today the class I started today at 7:30 because a little bit of AWS was remaining for your batch. So 7:30 to 8:45 till 8:45 I completed a topic of AWS today. Next Monday also I will start at 7:30 only, so that we can finish off the IAM topic is remaining for you. But
Mm-hmm.
next Monday also your DevOps class will start at 9 o'clock itself. But from Tuesday, or if either Tuesday or Wednesday, when we reach, we will be back at 8 o'clock itself, because this happened because the AWS and DevOps got overlapped for 1 or 2 days because of this reason. Right. So today also DevOps started. I told that 8:45 will start, but I ended up starting at 9. So next Monday also it starts at 9 itself, or let's say 8:45, whatever. It starts at that point of time only. If I can finish off on Monday, the AWS part, it is fine. I don't want to rush with the AWS. If by chance it extends till Tuesday, because it will not take more than one session. But if in case goes to Tuesday, at least on Wednesday, we'll be back on track where we'll be doing only DevOps from 8 o'clock itself, the way it was supposed to be. Okay.
Tomorrow, do we have any session?
Tomorrow we have a session. This Saturday only I'm keeping it, which will be only for this Saturday, not from next Saturday, just to make sure we can finish up the gap that we have introduced because of my delay in my vacation. So what we shall do, we shall be tomorrow at morning 8. We shall set for DevOps. Okay.
Yeah.
And yeah, Monday once again on time only it'll go on, right? So Monday once again at 8:45, but from Tuesday it is back on track. We'll do at 8 or 8:30. 8:30 will be good. Is it? 8 o'clock is a little difficult for me to get up. 8:30 is fine, right? Yeah. So we'll do it for 8:30, or we'll see. I mean, uh, if I get habituated enough to get up at 8 o'clock, we'll do at 8 o'clock. Anyway, now I'm getting up, coming at 7:30, right? So for Prasad, Karthik, Mallikarjun, Vignesh, since your one session is still remaining on AWS, that will be done on Monday at morning 7:30.
Sure.
Okay, Vishal.
The meeting and the password is same for everybody. I mean 800 WD, that is the password. T at 800 WD. This is the meeting ID. So the guys who are joining for DevOps, join the meeting at 8:45. If still AWS is going on, I mean just stay and sit and stay silent. I'll finish off AWS. I'll take Mallikarjun for a tea. I'll come back and I'll start DevOps. Right. So I'm targeting 8:45. If not, maximum 9 o'clock. But join at 8:45 for the DevOps people. And AWS people join at 7:30 itself. Okay?
Yeah.
Vishal.
Okay.
Thanks.
7:30 DevOps AWS classes.
Yes.
Yeah. Okay.
Join
Then.
at 7:30 itself. Fine. So only IAM is remaining for you, and a little bit of, I think, a doubt clearing session is required, which Vignesh will come to classroom. Karthik also, if you want, you might join him. So we'll sit for some half an hour, 1 hour. We'll clear up the doubts later. No, not right now. Let's first finish off and be on track, because we have got a little bit out of track. Let's come back into track. Then we'll take out some time and do that. Fine, cool. Everybody clear? I'll put this file on Drive, right? I think there has been, like 3 different groups somehow got merged or something happened. And so I'll just, add the other people in the Drive accordingly so that everybody can get it. And I do not need to keep it in every other folder. So I'll do something, somehow you will get it, right? Don't worry about it. So that's it for today. I'll stop it over here. I tried to keep it short for the DevOps part, just 1 hour I took, but typically we'll make it 2 hours later. I kept it 1 hour. I just tried to give you the idea because this was very, required to take. This is the main idea of DevOps. Go through this notepad file ever again if you need. I don't think you will need it, but still, if you need, go through this notepad file, because this is a good way of, it has been written in a particular way. Go through this. Have this idea with yourself. Tomorrow we shall start with the first tool, which is Git. Fine. Git is where we start. We start with Git. Slowly we shall go to GitHub, and in that way we shall complete this part. Clear, no? Yes. We have
Yes,
total 11 things to do. A lot of things. On 15th of February or probably 18th of February, I am going out of city. So we will not rush, definitely, but we will try to take it in a very structured way, and as less of we can do, right? So everybody make sure that you will join on time. In case you join the meeting and see, let's say the morning 7:30 specifically for Mallikarjun, Prasad and Karthik, and please join at 7:30 itself. Just try to see the link. The link password will be that one only. Doesn't change. If by chance I get 5-10 minutes late, just hang on. Okay. Mostly the meeting will start. If you see that Vishal is not there in the meeting, he joins 5 minutes late. Just hang on. I'll definitely try to make it exactly at 7:30. At most 7:35 it can be, right? Okay, because I have to come here, right? So I'm from my home. I have to travel to the institution and do that. So in the morning, one thing is I feel so cold to get up, right? And I don't feel like leaving my bed. Just wait for 5 minutes, 10 minutes. I definitely will be there on time. Chalo. Thank you. I'll close the session over here. Thank you so much. Bye bye.
Thank you. Bye.
Bye bye.